Hello and welcome to End-to-End Solution Architect session. Today I'll be talking about Terraform custom modules, source, module source and its versioning, and ultimately I will show you how to publish your custom module into Terraform public registry. So let's start. Before jumping into the hands-on session, let me give you few theoretical knowledge about Terraform modules. And in this session, I'll be covering Terraform project structure, the best practices, create custom module. I will show you how to create custom modules, module source and versioning. I'll show you both local source and remote repository source as well as versioning of modules, and publish custom module in Terraform public registry. So our first part is project structure. Now you must be knowing in Terraform that there is no provision in any fixed name format. Only the extension of the file matters. Means your Terraform files should have extension of TF. That means Terraform. But here in this case, if you see that I have mentioned, it is versions, main, variable, output, these 4 files, but these names are not fixed. You can give ABC, XYZ, anything which is readable and meaningful for you. But what I recommend and I suggest is that use these 4 files to structure or organize your Terraform project. All the versions you are using for your Terraform project should come under versions.tf. I will show you each and every file practically in hands-on session just in few minutes, but before that I'm just telling this theoretical backgrounds. Main is the resource part, means a resource file where you actually write all the resource code. Then next is variables. You keep all the variables over there, define all the variables, and output, you mention all the outputs which should be printed after execution of your Terraform. Now you have noticed that there is another file I have used. It is .tf vars, and the extension is very important. It is .tf var. The name can be different because I have mentioned over here that we can use these variable files for particular environments. If we are using dev environment, then let's keep a variable file for dev, which is dev-app.tf words. If it is production, then production-app.tf word. In my next session, I'll be talking about how to manage multiple workspaces and play with multiple environment. But for this session, as of now, just keep in mind that the tf-vars file keeps all the variable values in key value pairs. That's it. Apart from this Terraform files, means .tf and tf-var files, we have .terraform, that is the directory. When we initialize the Terraform, it stores the required providers. Next is the terraform.lock. It is for lock management. So if you are working in a team and multiple people are working on the same project, so you need a lock-in mechanism. So this terraform.log.hcl provides the locking mechanism. The next one is terraform.tstate, which stores the state of the Terraform infrastructure. It helps in checking the desired state and current state. Now on the right side you see that it is the module part, and when you write the module, I will show each and every steps in just few minutes. But before that, the module structure will also have the same kind of files, which is versions.tf, main.tf, variables.tf, and output.tf. You have noticed that modules don't have any Terraform directory nor the lock file, neither this Terraform state file. Yes, it will not have any those kind of files. Only the Terraform codes which exist, it will be in the module file, and those module will be actually referenced in our main project main tf, where we are defining the resources. Here we will be defining the modules as well. So we will be defining the modules over here in my project, and we are actually implementing the modules in particular modules over here. Now let's proceed. Now when we are writing a custom module, the versions file is different for project and module. For project, you keep the version file with Terraform required providers, and you add the state management. In this case, I will be using S3 for Terraform state management. And the next one is you mention the provider as well, because it is your project file, project version. But in case of Terraform module, you will need only the required providers only. You don't need the backend configuration or provider block. So that's the difference between project and modules version. The next one is very important, and we get confused in variable mapping. So what happens when we are using Terraform modules, that we pass the variable value of the modules from our project file. So basically the flow works is, in our project we have a variable tf file where we used to mention all the variables like you see over here. These variables are used in our main.tf file, and I am using these names only, like main.tf, variables.tf. So whenever you hear that variables.tf, it means that all the variables are in variable.tf. When you hear the main.tf, it means that all the resources are defined in main.tf. Okay, so main.tf uses all the variables which are mentioned in variables.tf to create any resource. Now in this case, I am using an example. I am using a module called ECS cluster. I will go in detail, but at this part, just understand that how the variables are mapped. So in my project, both the files are from the project files. It is variables are mapped like this. Now the next part is the modules. Now we have this in our main.tf project file. We have defined this module ECS cluster, and we are passing basically 4 attributes of this module. Okay, the first one is source, which is to mention that from where it should pull the module code. So that is not the attribute we will be passing. It is to point the module location. The next one is create ECS cluster. That is the module. You see this red arrow, it is mapped with the variables of the modules. Next is ECS cluster name. This yellow arrow goes to variables tf module. All the attributes of the module defined here. Now when you have your variables file for your module, the next part is you pass the values which are actually coming from your project main.tf to modules main.tf, because ultimately the resource is being created in modules main.tf. In our project file, we are referencing that module, but ultimately the resource is being created at the modules main.tf. And you see again that how the module main.tf is getting mapped with the variables which it has mentioned in the variables file of the module. So these arrows are the mapping which shows that how it is mapped from the project side to module side. If I want to show the complete part, and I said that we are going to use a tf files as well, which will keep all the variable values in key value pairs. So it is the file which is dev-app.tfwords. So the flow of the variable value is actually, first it comes from tfwords, which is mapped with the project variable files, and all these variables are mapped or referenced from the main file of the Terraform project. Again, if I say main file of Terraform project, it means that the file where we are referencing the module or creating or defining the resources. The file name can be abcd.tf, but basically the file where we are defining the resources of the modules. So now from the modules, these variables are mapped with these attributes, and these module attributes are getting mapped with modules variable file, and modules variable file is passing that value to modules main resource file, where the resource is actually getting provisioned. So this is the whole flow. Now next, understand the module source and versioning. In the last slide, you may have noticed that we have something called source inside this module, and source means it points out where is the module located, so it can get the codes inside the module. Now you can point out the location by two ways. First one is local source. So when you have that module in your local file system, then you can mention by the absolute path or by this dotted path which text module is available. This is the local source pointing. And now next thing is remote repository source. So Terraform also provides one feature where you can refer your modules from the Git repository. So if you have kept your modules in the Git repository, you can use this URL format to pull your modules from remote Git repository into the system where you are running Terraform. So there are few parts in this big URL, and let me describe that. First is git and then double colon. It is the source which saying that we are using Git repository. The next green part is the complete git clone URL of the GitHub account you are using. The next, don't miss this double slash. So after this double slash, this is the orange part which is the complete path of the module. If you have any multiple directory structure, then mention over here. So this is the path to the module folder. And the next is, after this question mark, reference or ref equal, either it is the branch name or you can use the tag. So if we provide this whole thing, the git clone URL, path to the module, and mention that which branch or tag it should pick up, then when you run Terraform in your system, Terraform will not look the module from your file system, but it will check from the Git repository you have mentioned over here. So here you can see that in my case, I have the Git repository, which is the Terraform repository. It has the directory structures as providers, AWS, modules, and this is the module name actually, which is E2ESA module AWS CS cluster. And I have copied the whole path over here, path to the module folder. And you see that since my code is in main branch, so I have referred it with main. Well, now here comes the versioning. So you know that you will be committing multiple versions of code, and for the stability of your module, you want to share or pull the module codes based on the version. So it means that when you are committing or pushing or publishing your code in your GitHub repository, create a tag. Suppose you have created a tag called v100, and you can refer that particular tag by this ref equals v1.0.0. It is as simple as that. So it is all about the module, how you can source the module, and how you can use the module versioning from your remote repository source. Now let's go to the hands-on part of it. Here is the Git repository of end-to-end solution architect. I will share this URL and you can check the code directly from here. You will have this Terraform, one Terraform repository for AWS ECS cluster, which I have published in Terraform public registry. I will show the steps how to publish that. But here is the link for all the Terraform modules and the examples I will be using in this session. Now, let me open the Terraform code. I have a very simple code which we are using in this session, that is the module. So I have this module on the left side, if you see. So module, this is the part. And here let me open the projects. So on my right side, it is the project, and left side is my module. So as you see, in my module versions, we have only the required providers. And in my project side, in versions file, I have required providers. I have set up the backend, Terraform backend with AWS S3, and also mentioned the provider. Here in this case, I am using AWS as my provider. The next in the module, let's check our main.tf. And on the right side, let me open that main.tf for the project. So you see that project side, I have defined this module, means referenced this module, and I have used this sourcing as a local source because it is in my local file system. Okay, and here is the variables which are actually mapped by the variable files with this, as I showed you just through the slides. Okay, and next let's go to the variable files of module on the left side, and on the right side variable files of the project. So in case of variable files, you see that we have defined these three variables over here, and we have also defined the same variables to link in the module side variable files, and they are defined with attributes like description, type, and default values. Now, as I said that I am using a tf-vars for variable values, so let me show you the tf-vars for the project I am using. So it is dev-app.tf-vars. You see that I have this variable values mentioned over here with key and value pair. So here it is a very small example where I am saying that create ECS cluster true, ECS cluster name, I am just adding this cluster name and setting this container insights as false. So it is supposed to create just a cluster in AWS ECS. Okay, so let me run that code. So let me browse to that location, examples, then ECS cluster. Well, so do a Terraform init. Terraform has been successfully initialized, and meanwhile let me show you one thing, that I am logged into my AWS console. let's go to ECS before I create that. So let's see that if there is any cluster available over there. Go to cluster, and we don't have any cluster over here, as you see. So now let me run this code, which will basically run the project and this main file over here. And to run this, what we will do, we will write Terraform apply directly. I'm not going for the plan or the validate, because when you do that apply, it will basically do the plan and also the validate. Okay, now I will pass the variable environment variable files as well. So it means that hyphen var hyphen file equals and the file name dot tfvars. Also, I will be passing one variables runtime for the created by. This is not mandatory to pass any variables runtime, but it is the structure I recommend to follow, that when someone is running a Terraform script, it should capture that who is running that code. So when the resources are getting provisioned, it will capture in the resource tag this particular attribute that the resource is created by this. Okay, so Terraform apply var file, which is dev hyphen app.tfvars, and var equal to created by this. Now let's run this, and it's showing that it is going to create one resource, 0 change, 0 destroy. So let's give it a try. Yes. Well, apply complete successfully. So let's go to AWS console, give a refresh over here, and you see that our cluster has been. So what we did, we just used the ECS cluster module which we created and referenced that in our actually main project by this pointing this local sourcing, and passed the required values. And how do I know that what are the values I have to pass? It is that you open the main resource file of your module, and then you will find that what are the variables actually required. So you have to pass those values from your project side. So again, I'm opening this project main resource file. You see that since in module we are using the create ECS cluster name and container insights, that's why I'm passing this. Also, I'm passing these tags which are being used as a tag. Let me show you that how the tag is working, because you may have noticed that I'm generating few tags over here. So if I go to this cluster, click on the cluster and go to these tags, and you see that all these tags have been generated: project, environment, created by, created on, and resource. Well, so this is how we create custom modules, and you can create the nested modules as well. It means that calling one module or multiple modules inside another module. So on the left side we have these modules, but inside that you can reference other modules which you want to get advantage of. Well, so our custom module is ready. Now the final part of this session is to show you how to publish the module in Terraform public registry, and there are 4 steps for it. Let me explain that, and after that I will show you practically. The first step is that create a public repository in GitHub. You should have a public repository in GitHub, and the name of that repository must be in this format with Terraform hyphen the name of the provider, whether it is AWS or Azure or GCP, it should be like that, and hyphen, and then the last part is your module name. In our case, it is a ECS cluster. So the first part is Terraform hyphen, second part is the provider hyphen, then rest of the part is your module name. So you can have multiple hyphens in your module name, that doesn't matter. Next is publish the module code in GitHub repository. So as I see in this screenshot that I have published my module, the test module which I was explaining for this AWS ECS cluster, inside my E2E solution architect Terraform AWS ECS cluster repository. So my repository name is Terraform AWS ECS cluster. This is my repository. And one very important thing to note that you need to have one repository for one module. It is a one-to-one mapping. You cannot keep multiple modules in your single repository. So one repository, one module. Since you have this ECS cluster, it is the one module and it is the one repository. The next third step is log into registry.terraform.io with your GitHub accounts credentials. Means through GitHub you have to log in registry.terraform.io. Then when you check the publish drop down, you will find there are two options, provider or module. Definitely you are publishing module, so click over that. And the fourth or the final part is when you click over this module and you have made this already published your module in the GitHub repository you created, and once you logged in this registry.terraform with the same GitHub account, it will automatically pick up that what is that module eligible to be published in Terraform public registry. So when you click on this publish module, you will find a drop down list where it will show the eligible modules to be published. You select your module from this drop down, accept the agreement and the terms of use, and then click on publish module, and your modules will be published. And let me show you how it is done. So here I am in my E2 Solution Architect GitHub account. So let me go to that repository which I created for a module, and this is my repository which I created for the module ECS cluster, which is Terraform AWS ECS cluster. Go inside that and you see that we have only these 4 files with for a particular single module. So one repository for one module. I have pushed it here. It is in the main branch, and I have also created one version tag. So I have created this v1.0.0 as version tag. So I have released my code. Okay. Now the next part is, as I said, open registry.terraform.io, and since I am already logged into my Git account and I created my login in Terraform registry, so it is already logged in over here. You go to that publish option, click on module, and it will open like this. And as I have only one repository which is eligible as per the Terraform module nomenclature, so that's why it is showing like this. So you will select this, select the terms and conditions over here, and we'll publish the module. But as this module is already published in Terraform, it is saying that was already published. So if I need to push any new change, I have to release a new version in my GitHub repository for that module, and then again I will be able to publish that. Okay, so I am just going back and showing you that. Let me go to my profile, which will say that once you created your profile, it will show your profile like this, and after publishing your module, it will show like this, that in your module you have this module published. And if you click the module over here, you will find this instruction or the code whoever wants to use your module in their code. So it is basically mentioned the versions as well as the source and what are the inputs required. It has already captured from the variable files, outputs, dependency, resources. And there is a readme. Readme is basically whatever you have in your readme file over here. See that in my case, I have this written in my readme, a Terraform module to provision AWS ECS cluster. So the same you see over here. So you draft your readme well, it will be showing over here with all the instruction, and it is the source code which shows. So if you click that, it is the direct link for your GitHub repo. So far we have learned that how to create custom Terraform modules, module source and versioning, and how to publish your custom module in Terraform public registry. I hope you got a good knowledge of how to play with Terraform modules. More you practice, more you learn. Thank you for your time, and for the next session I'll be talking about few more things of Terraform, which is Terraform workspace and environment profiling, how to collaborate with multiple teams and multiple environments basically with Terraform workspace. Thank you for attending the session. If you have any query, please write in the comment box or reach us at e2esolutionarchitect.com or email us at info@e2esolutionarchitect.com. Thank you for your time. See you in our next session.